Hey guys, how you going? In this video I'm going to be showing you how to use the mutation observer in JavaScript. Okay, so basically this right here is a very powerful tool which lets you observe or react to changes in the DOM. So for example, you're able to be notified when an attribute has changed its text content or its attributes, or even when child nodes have been added or removed from a parent node or element. So definitely a very powerful tool worth learning or at least knowing about. So it can definitely come in handy when using external libraries which don't provide their own events. So for example, if your website is using a library which makes changes to the DOM and you want to know when those changes happen, you can definitely do that using the mutation observer. So I'm going to be showing you a few examples of how to actually use this, and of course what you can actually observe with the mutation observer. So let's go inside the text editor right here. So essentially we're going to be using this unordered list with a class of summary as the test subject for the mutation observer. We're going to be observing or listening for changes on this particular list. Alrighty, so let's first get a reference to the list in JavaScript. So we can say, of course, const myList is equal to document.querySelector and pass in here the class of summary. Alrighty, and then we can go down here and we can start using the mutation observer. So the way the mutation observer works is essentially in three main steps. So let's take a look at those three main steps. So the first thing is going to be making a new mutation observer object. So you're going to need a actual mutation observer itself, very similar to the way Ajax works. So once you have a mutation observer object, you can then tell it what to observe. So in this case, with this list, for the first example, we're going to be observing changes to the attributes. So basically right here, we're going to tell it to observe changes to, of course, the attributes. And the last step is going to be what you're going to do with the changes. So we can say what to do with the observed changes / mutation. So it's going to let you pass in a function which lets you, of course, do your own custom logic or behavior for when the mutations have been made. And that is the 3 steps to using the mutation observer. So now let's go down here and firstly do the first step by making a mutation observer object or instance. So we can say const observer is equal to a new mutation observer. Alrighty, so now this is going to give you right here a mutation observer, and it actually takes in a function, and that function is going to be step 3. But for now, let's come back to that function and instead go down to step 2, which is, of course, tell it what to observe. So let's go down here and say observer.observe. And this function right here is going to take in your target node. In this case, it's going to be the list. So we can say my list just like this. And right here is an object you pass in, which is a list of options. So in this case, it's going to be, essentially, you're going to tell it what to observe. In this example, it's going to be attributes. So we can say here, attributes like this, and you can say true. So now we've said to the mutation observer, observe this element or node for these particular changes. In this case, of course, just attributes. Okay, so now let's move to step 3, which is, of course, your own custom behavior for when the mutations have been observed. So we can say here, we can pass in the function. So the function is going to give you an array of mutation records, or in other words, an array of changes. So we can say here mutations just like this, and now we have our function. So as I said, this will be an array of changes. So for now, let's keep things simple and only say console.log mutations to actually see what is going on. So this is the basic usage right here, so very few lines of the mutation observer. It is now ready to go. Alrighty, cool. So let's go down here now and actually make changes for it to observe. So we're going to use a set timeout to change the attribute on the list. So we can say set timeout and pass in here a function. This function is going to simply say myList.setAttribute. We're going to change or set the ID for the list to something like some random ID. So now we have a change being made 1 second after the page loads up. Alrighty, let's now save this and refresh the browser, and then wait 1 second, and we get right here in the console an array of mutation records or an array of changes. So this right here at element 0, so the first change that was observed, we can see we get a detailed list of the particular mutation or change. So for example, we can see here first right off the bat how we can see attribute name is equal to ID, so we know the ID has changed. Down here we also get a target, so target is going to be the element or node of which the attribute has changed on. In this case, of course, it's going to be the same thing we actually passed in, so of course the list element. And lastly, we get type as being attributes. This is just telling you that this particular mutation record is of type attributes, so an attribute change. Alrighty, so that is the basic usage of the mutation observer, and of course with this array you can essentially do what you want with it. So let's take a look at an example of simply just logging out to the console what attribute has changed and what the new value is of that attribute. Of course here we don't actually get the random ID value that I gave the ID. So let's go back inside the text editor, and we're going to essentially loop through each mutation. So we're going to say mutations.forEach. I'm going to say here record, and firstly, so for each record we're going to simply console.log the record. So of course we can see what's actually happening for each iteration, and we can also go down here and do a bit of a safety check. So we can say if record.type is equal to attributes, then do something. So you might see this come up quite a bit in the usage of mutation observer. It's simply just saying you're making sure that the change was for attributes, because you can actually pass in a few different options here, which we'll get to later on. So essentially you're just saying here, just making sure that the change has been an attribute change. Alright, so inside this condition we can say right here const changed attribute name is equal to record.attribute name. In this case, this will give us, of course, ID. So we're getting this this property right here. And let's go back inside here, make a second constant for new value. This will be the changed value for the attribute. We can say record.target.get attribute for the attribute name, changed attribute name. So we're simply just calling the get attribute method on the element to get the attribute value for the changed attribute name, in this case of course ID. Then we can simply say something like console.log attribute changed new value for, and then pass in here the changed attribute name, and we can say something like of course new value, and close that off. So attribute change, new value for this is this. Save this and refresh once again. We can see here after 1 second, of course we get the record, but also we get here attribute change, new value for ID is some random ID. So that right there is an example of how to use the mutation observer to listen for changes for attributes. Okay? Now, with this, you can also pass in a few more options for attributes. For example, you can tell it to only observe changes for particular attribute names. So, if I want to only listen for changes to the element class, I can say attribute filter and pass in here an array, and I can say class, for example. So now it's still going to observe attributes, but only the class attribute. Alright, so now if I was to duplicate this line and say set attribute class and make the class something like summary and then another class, for example, now we don't expect this particular mutation to appear inside this loop or even inside the mutations. So let's save this and refresh once again. Wait a second, and we get right here the mutation record. We can see now we only get a single mutation record, and we get it for the attribute name of class and not ID. And of course down here we get new value for class is this guy right here. So definitely a useful property. Now the last one for attributes is going to be called attribute old value. So we can say here attribute old value and set that to true. The default is false, and this right here is going to give you the old value for an attribute. So of course here we can see the class was originally summary, so to get this information it's quite easy. You simply say attribute old value is true, then I can save this and refresh. For the mutation record, if I expand this, the old value property is now filled with the text summary, and this right here is of course the old value for the attribute of class. Alright, so definitely very useful stuff. And that is all I have for the attributes example. So now let's take a look at another example, and that's going to be listening or observing changes to the child's list. So basically when elements or nodes have been added or removed from a parent node. So let's just get rid of all this stuff. Okay, and we can go inside the options and specify the options for listening for or observing changes to the child list, and this is going to be called child list. Okay, set this to true and you are now good to go. So now the mutation observer is going to observe when child nodes have been added or removed from the list element. Alright, so firstly, we might go in the set timeout and actually make these changes. So we're going to remove the last, let's remove the first list item from the list. So we can say mylist.removeChild and pass in here mylist.firstElementChild. So now, of course, we want to actually listen and react for when this happens. So let's go inside the mutation observer for each loop, and we're going to firstly just console.log the record, and that is basically it. Let's save this, refresh, wait 1 second, and we get right here, of course, the list item has been removed from the first spot, and we get here mutation record for that mutation. Expand this and we get here removed nodes. It's a node list of the removed nodes, in this case the list item. Alright, if I was to expand this, we can see we get all of the information for that removed list item. Of course here the inner HTML lets you react to changes in DOM, etc. So we get here, of course, the list of removed nodes. the same thing works for up here, added nodes. So let's go back inside here and actually add a node. So we can say const new ally to make a new list item element. I'm going to say document.create element and pass in here ally. We can then say something like new ally dot text content is equal to hey how are ya? Then we can say my list dot append child, and we can pass in here new ally. So now we expect to see two mutation records, one for the removal of this child and one for the addition of this child. Let's save this, refresh, and we can see here we get two records, of course. Added nodes, nothing. Remove nodes, of course, same as earlier. Down here we can see now added nodes as being a list of nodes which were added, of course. So in practice, let's go back inside the editor and we can go inside here and we can do a very similar thing. So in this case, and same for the previous case, we know that we're passing in only child list. So it may not be completely necessary to actually check for the type. So instead, we're going to go straight in and we're going to say if record.addedNodes.length is greater than 0, then we can simply say something like number of nodes added. And we can say, of course, record.addedNodes.length. If I use template strings here, it might actually work. So we can say record.addedNodes.length for the number of added nodes, and do the same thing for the removed nodes. So of course, pretty basic example of how to actually, of course, use this. So we can then say removed nodes and just say here removed, and save this, refresh, and now we see here nodes removed 1, and of course nodes added 1. So definitely, take what you want from this mutation record and of course use it for your own personal or specific use case. Alright, and that is how you can listen for changes to the child list. Alright, next up is going to be changes to text, which is very similar to the child list changes. So let's go down here and of course just remove all of this stuff once again and remove all of this stuff. So for text changes, basically in most cases when you're making changes to text, you're going to be using the text content or the inner HTML properties. So for example, if we were to say my list dot first element child, so we're going to be taking a look at essentially text changes for the first list item. So changes to the stuff inside here. So we're going to say my list dot first element child, the first list item. We're going to say dot text content is equal to something else. So in most cases, you're going to be using the text content property to make changes to text. All right, or alternatively, the inner HTML property. Now, both these examples, the way they insert text is by basically removing all of the previous text nodes and then adding new text nodes for the new text. So, technically speaking, this isn't changes to text, it's more changes to the child list, since you're removing nodes and then re-adding new nodes with the new text. Okay, so with that being said, let's just keep this the way it is and log out each record. Alright, with this change, we should see changes in the console. So let's save this, refresh. We see here nothing. Sorry, let's go back inside here. I forgot to make this my list.firstElementChild. So of course, I'm going to pass in this time the first list item. Save this, refresh once more, and now we should see in the console mutation record. So let's expand this. We can see once again we get removed nodes, a node list of text. So we removed this text node, which had the information, let's see react to changes in the DOM, of course. Right, now we also get added nodes with text. This text was something else. So, as I said, with text content, you're removing the previous node and you're adding a new text node. Okay, so that's why it is technically a child list change. So, if you want to, of course, use this information and do an example of actually listening for text itself, you're going to want to check for essentially changes to, you're going to want to check that the added nodes and the removed nodes were actually text nodes. Okay, so that way you can accurately say that this was a change to text, if that makes sense. I'll just show you in code, it's a lot easier to explain. So we can say here, then we can say record.addedNodes.length is equal to 1. So if there was a single added node, the new text, okay, and we're going to say record.addedNodes at index 0 dot node type is equal to node.text node, then we know there's been a change to text. So essentially what's happening here is the node type property of this node is going to give you a constant, one of these values. In this case, we're saying, is it a text node? Okay, so if there was a text node added and a text node was removed, so we can just copy and paste this, then we can say that of course the text has been changed. In most cases this will work, but in some cases maybe not. Maybe you have multiple removed text nodes, you'll need to adjust accordingly, but this should work in most cases. So we're basically saying if there was a single text node added and a single text node removed, then we can do something. Alright, we're going to say console.log text changed from this. So record.removed nodes at index 0 dot node value. So node value is going to give you the actual text for the text node. We can say text change from this to, and then pass in here the new value. So record.addedNodes at index 0 dot node value, and then cut this off right here. So it's a bit more complex, but essentially we're just checking that the changes to the child list were text node changes. Alright, save this, refresh here, wait a second, and we get here text change from lets you react to changes in the DOM to something else. So it works just fine. Alright, cool. So that is essentially what you might do to listen for changes to text, because in most cases, including inner HTML changes, so let's make this and something else, this is going to work. Save this, refresh, and now we can see here we get two of these changes, something else, two, and something else, and of course the previous one right here. So this is going to work for text content and inner HTML property changes. Now, it's not going to work if you use inner HTML and add something like a break tag, for example. So now we're introducing a second node here. The first one is an HTML element, the second one is a text node. So now the length is going to be 2 for the for the added nodes. Let's save this and refresh, and now we can see here that we get, I might just remove the first one to make it simple. Okay, save this, refresh once again. We can see here that for the record, we get added nodes, a break tag or a break element, and a text node, and here we get just a text node for the remove node. So in this case, we don't get that console log. So to make changes for that, we have to say 2 for the added nodes.length, and of course you're going to need to adjust this for your own particular scenarios, but that is how you can actually do it using the mutation observer. Okay, cool. So now we've covered text. Let's take a look at now more text changes, but this one is it's going to be text changes to a text node itself. Okay, so I thought I'd cover it because it's actually part of the mutation observer. So let's get rid of all this stuff once again and refresh from scratch. So we can also remove this child list. So to observe text changes for a single text node, you can use character data. Okay, and this one works a bit similar to the attributes. So you can say right here true, and now here you're going to pass in an actual text node itself. So let's use this text node right here as the example. We can gain access to this text node by saying mylist.firstElementChild child nodes at index 0. Okay, so the first child node of this list item is going to be the text node right here. So we're passing in a text node to the mutation observer observe method, and we're saying character data as being true, which lets you observe changes to the character data or text within the text node. So to make this modification to the text node, you can say right here mylist.firstElementChild child nodes, or you know what, I could actually use the first child property. So I can say first child right here. It does the exact same thing. So we can say here first child dot node value is equal to how's it going. Alright, how's it going? So now this is a different way of updating text on a page. It's going to be editing the text node directly itself. So now with this particular change, the observer can actually know about it. So I'm going to save this, refresh, and we can see here, of course, how's it going? That worked just fine. The mutation record tells us here that the type was character data and the target was text. So very similar to the attributes option, we can simply say to get the new value, we can say something like console.log. We can say text has changed, and we can say new value, and we can say record.target.node value is going to give us the new value. And that's basically it. Save this, refresh, and we can see right here, new value, how's it going? So it works perfectly fine. So you can also give it an old value option once again. So you can say character data old value and make that true, and now the old value property is going to give you an actual value. We can say here old value is of course record.old value. Save this, refresh once again. We can see here the record gives us old value, of course that same text from earlier, and we can see here new value, how's it going, old value, and that text from earlier. Okay, so that is how you can listen or react to or observe character data changes on text nodes. Alright, so for the last example here, it's going to be subtrees. So essentially you're able to, let's get rid of all this stuff once again to start fresh. You're able to pass in an option to the observer to say subtree is equal to true, and this is going to let you listen for changes for the element you pass in or the node you pass in and everything else within it inside the subtree. Okay, so what this means is if I was to make this observe my list, so the parent element, and then change the attribute on, let's say, this list item, then we're going to see it appear in the mutation record. So let's go here and say attributes, and we can say true, for example. Then go down here in the set timeout And we're going to say firstly mylist.set attribute. We're going to change the ID to once again some random ID like previously. We're also going to say mylist.firstElementChild.set attribute and make this another ID. So now we're making changes to not only the parent but also one of the list items. So now with Subtree turned on, we should see records for both of these changes. Let's save this and refresh. We get here 2 records, of course, one for the target, the main parent list, and one for the actual list item. And that right there is why the target property is useful, because the target is not always going to be the same node you actually pass in. And just to further prove this example, if I was to take Subtree off, then save this and refresh, we can see now we only get the single record, of course, for the target you actually pass in. And one last thing for this video is going to be how to actually say to stop observing changes. So we can do this by saying observer.disconnect, and this right here is going to basically say stop observing changes for this stuff right here, and you should always call this if you know you are done observing changes. Alright, so now we don't expect any changes to, of course, appear in this callback function because we're calling this before this set timer has been executed. Let's save this once again for the last time for this video, refresh, and we can see right here we get no changes. Alright, and that right there is the mutation observer in JavaScript. Thanks for watching, guys, and I'll see you later.